Hello, a warm welcome to you all. Today, we'll be looking at blockchain fundamentals and also going over Kaia overview. Without further ado, let's get started. So, what is the blockchain? The blockchain is a distributed ledger with a growing list of records, which are blocks that are securely linked together via cryptographic hashes. You can think of the blockchain as a database that is consensually shared and synchronized across multiple locations, geographical locations, or even institution, or even computer, which act as nodes. And each of these nodes or participants have an independent copy of the current state of the blockchain, and in the case where a node is down, each of the other node keeps the blockchain running, alive, and also secure, right? So each of these blocks, which are batches of transactions, contains a cryptographic hash of the previous block, a timestamp, and also transaction data. As you can see above, the term blockchain was coined from block and chain, and which means that each of those blocks, right, has the previous hash of the previous block, and which makes them effectively form a chain. And according to this image that we have on the right hand side, we have block one, block two, block three. Block two has the hash of the previous block in it, and block three has the previous hash of the previous block in it. So this is the concept of the blockchain, really, right? Also, you can conceptually think of the blockchain as a state machine, which has two major components: the initial state, which has the current state of the blockchain. Take, for instance, the accounts and its balance, and also the transaction. So transaction by default are a set of instructions to like change the state of the blockchain. So meaning that we have a state and also a transaction. So the image on the right shows this blockchain as a state machine, meaning that we have an initial state, a transaction, which is the transition function, and the final state. Now, a practical way to look at it is a user has a balance of Kaia, say 100 Kaia. This is the initial state on the blockchain. And this user initializes a transaction to send 10 Kaia to another recipient or beneficiary address. This is the transition function or transaction. Now, once this transaction is completed, there's going to be a final state, which is going to have the current state of the blockchain. In this case, the sender's balance is going to reduce and the recipient's balance is going to increase, right? So this is the concept of thinking of the blockchain as a state machine with also a transition function such as transactions, right? Also, we're looking at blockchain core component, and today we're looking at four major core components, which is cryptography, consensus, distributed network, and also smart contract. All right, so let's take a look at them one after the other. The first is cryptography. Cryptography, in literal terms, is the art of creating and keeping secrets, but in today's world, it is done using complex mathematical algorithms. In the context of the blockchain, cryptography is important for the following reasons: for digital signatures, hashing, and also key pairs. Looking at the importance of cryptography in these functionalities, first, digital signature, right? So the importance of digital signature is to foster integrity, right? So when you sign a message using your private key on the blockchain, a change in this message will invalidate the signature, and anybody receiving this message, we know that this data has been tampered with because you literally signed the transaction with your private key. And if there is any tampering or any modification, it will reflect, right? So the second important use case for digital signatures is non-repudiation. So when you sign a transaction and this transaction is submitted, you cannot claim later on that you did not sign this transaction because, of course, your signature can be verified for the transaction submitted. Really important. Two things: integrity and also non-repudiation. Moving forward, we have hash functions. Hash functions are like a mathematical function or algorithm that takes in an input, right, and gives out a certain input, usually a fixed length of number or a fixed number of characters, basically. So an hash function is deterministic, meaning when you input a large size of inputs, basically you are expecting a fixed number of character. This is what we mean by deterministic. It's also fast. It's one way. In the case where you put an input, you're expecting an output, right? But you can't take back the output and generate the input. It's also collision resistant, and A small change in the input generates a completely different hash. Two documents do not generate the same hash literally, right? So there are several secure hash algorithms that exist, but on the blockchain, we make use of SHA-256 and SHA-3. The image on the right hand side explains the concept of the hash functions. We have the input, we have the hash function, and we also have the output, which is the digest. Right, so it takes in the input fox and it passes through the hash function and gets a digest. But you can't take this digest through the hash function to get back the fox, and this is what we mean by one way, right? Moving forward, we'll talk about consensus algorithm. So consensus algorithm of consensus mechanism is the way at which blockchain reach a consensus or agree as to how to validate transaction or add transactions to the blockchain. So this is how the blockchain promotes trust and also the different nodes interacting with each other by agreeing to validating transactions. So what are the different types of consensus algorithms? Well, we have proof of work, proof of stake, we also have PBFT. There are quite a number of consensus algorithms in today's world, especially in the blockchain space. For proof of work, this is the algorithm used in Bitcoin, and this relies on energy by solving a cryptographic puzzle. For proof of stake, you have to deposit a certain amount of crypto assets, usually the native cryptocurrency of that blockchain. And once this is done, you have access to propose transactions, commit to these transactions, and also validate transactions. And sometimes this is done randomly based on the number of stakes that you have. And in the case where you are not performing your proposal duties or your validation duties, you'll be slashed. And the case also where you propose a faulty transaction, you also be slashed, right? Really, really important. So for practical Byzantine fault tolerance, this is the type of consensus algorithm that is used to cater for the need of like large networks that uses BFT. So when we say BFT, it's Byzantine fault tolerance, which means that when there is like a large number of honest nodes in a blockchain that propose honest transaction, a certain number of them, the transaction passes. Right. So for Kaya blockchain uses the Istanbul Byzantine fault tolerance algorithm, which is like an optimized version of PBFT. We'll get to that in a while. Moving forward, we also have distributed network. Distributed network, right, which means that the blockchain, right, has different nodes spread across different continents or geographical locations, and each of these nodes have independent copy of the blockchain, like I mentioned previously. So once a node is down, every other node keeps the blockchain running and alive because, of course, they have the independent copy of the blockchain, right? So for centralized, there's a single point of authority, which of course makes it a single point of failure. For decentralized, there are like key or multiple nodes that are like the single point of authority, which of course is not really good in this case for a distributed network, and which of course is why we have now migrated from decentralized to distributed to call ourselves distributed networks. Right. Also, smart contracts really. So, smart contract is a piece of code that runs on the blockchain, basically your logic, right? So, a smart contract is used to read the current state, perform logic on the blockchain, update the state of the blockchain literally. So all of the all of the logic that you want to write on the blockchain, all of the if else, if this do that, if this do that is done using smart contract. And depending on the ecosystem, on the blockchain architecture, there are different languages that are being used for writing smart contracts. For EVM compatible chains, they make use of Solidity. And for other ecosystem, they make use of Rust, Move, Gyro, and so on, right? So yeah, in this bootcamp, you'll be learning how to write smart contracts using Solidity because Kaya blockchain is an EVM compatible chain, right? So we have understanding KLVM. KLVM means Kaya Virtual Machine. So this is the runtime environment for running smart contracts, for executing smart contracts on the blockchain. So your smart contracts are programs that has conditions that are executed based on what has been specified in the smart contract, right? And so for this to properly execute, it makes use of Kaya virtual machine. And so because smart contracts are written in programming language and Solidity, they used to be compiled into bytecode in which the KLVM understands, right? And so once these contracts are compiled to bytecode, which KLVM understand, it's being executed, right? So KLVM is compatible with Ethereum virtual machine, and this means that it fully supports every development tools, opcode, and also source code. Right. So now let's talk about Kaya overview. So Kaya is the amalgamation of Clayton and also Finchia, which has brought about the rebrand Kaya. Now, what makes Kaya so unique? Kaya at its core has 1 second block interval, which means that it takes only 1 second for your block to be validated on the blockchain, and it has 4,000 transactions per second, which means 4,000 transactions can be handled in a second. And so these two unique features fosters or enables mobile app like performance and also support production with enterprise usage. All right, so moving forward, I mentioned the fact that Kaya uses IBFT, which is Istanbul Background Time for Tolerance. And this is what is responsible for the unique features of Glyphine, right? It has fast block generation time, instant finality, energy efficiency, really. Kaya at its core also is EVM compatible, meaning that you can build end-to-end DApp solutions from DeFi, NFT, gamings, and all of those things. Also, the different dev tools are compatible on Kaya, really. Right? All right. So having said this, this positions Gaia as the public foundational layer for tomorrow's on-chain world. And of course, for this reason, there are different use cases that are being built, ranging from DeFi, games, social infrastructure, wallets, even centralized exchanges, and also the different metaverse use cases that we have. So far, here are some of the ecosystem partners or products that we have. We have ClaySwap, which is number one DEX on Kaya, which is a decentralized exchange. We also have Swap Scanner, is number one DEX aggregator. We have different games, DeFi Kingdom, Work to Earn platform, Superwork, Iskra Gaming Launchpad, and also Mablex, right? Really. So these are the various use cases that you can build, right? And also we are focused on real world assets tokenization. We have different ecosystem partner. So having said that, you can also refer to some of these resources. If you have any questions, don't forget to drop your questions in the Discord channel. That will be all for today. I hope you really did enjoy the session. Thank you and see you in the next video.